Stanford University.
Welcome to yet another episode of CS193P. I'm Evan Dollick, in case you forgot who I was since last Wednesday. Let's get started with some announcements. Assignments 1A and 1B are due tomorrow at midnight, so if you haven't started, you should probably do so. And if you have any questions, shoot us an email at the CS193P at CS list. Troy and Paul have both had their office hours already for the week, so if you need some help, it'll have to happen over email, so just drop us a line and let us know. And if you get a chance to submit early, there have been some glitches already that people have sort of caught in the submit script. It's always nice to sort of not be scrambling around at 11:59 and the script is broken and you can't submit and you're all stressed out. One thing that has been catching a lot of people, and actually that Xcode should probably do a better job of, is even if you do a clean or clean all in your Xcode project, there will be a directory titled build, which is still often left inside your project folder. So you'll probably need to delete that by hand before you do the submission. I think quite a few people have hit that actually, and I'm sure that more will. Assignment 2 is we've got kind of a short turnaround between 1 and 2 because we started on a Wednesday rather than a Monday. We had to compress some time at some point. So assignment 2 is due on Tuesday. 2A is a continuation of the foundation tool that you've been working on. After today's lecture, you'll know everything you need to know for that. Assignment 2B, actually we're not going to really cover the topics for 2B in depth until Monday, which if you do the math, not a lot of time before the assignment is due. Luckily, it's a pretty simple assignment. And the assignment handout itself has a pretty extensive walkthrough. So even if you haven't, you can probably try and take a crack at it over the weekend. And if you follow the walkthrough, it should be pretty obvious. Other announcements, just a reminder, Troy and Paul, they've both got their office hours scheduled. From here on out, Troy is going to be on Mondays, Paul Salzman is going to be on Tuesdays. So definitely reversed, sorry. Well, either way, show up and somebody will be there to greet you with a smile and answer your questions. And the first optional Friday session is this Friday. It's going to be all about debugging, what happens when your app crashes or does something weird, and the first steps you should be taking as far as figuring out what's going on. This is really valuable. It's going to save you a lot of grief down the road once your programs begin to get more complicated. So I'd really recommend coming and checking this out. It's not to be missed. And finally, we have the class news group. For those of you who are into that sort of thing, it's Stanford only, and it's at su.class.cs193p. We do not yet have a Gopher site. You guys don't even know what that is, do you? Never mind. Yeah, question.
Is Friday's session filmed?
The question was, is Friday's session going to be filmed? Right now, the answer to that is no. We're looking into whether that's a possibility, but at this point, logistically, it's not happening. If we have an update on that, we'll definitely send an email to the list and we'll post it on the course website as well. Yeah, question?
The Friday session is a different room?
It is. Anyone have that room handy? I believe it's,
On the last slide.
was it on the slide? 200-205. So where that is, I honestly have no clue, but opposite corner. History corner, all right. Yeah, you can always use the iStanford iPhone app. Any other questions about the announcements, logistics, any of that sort of stuff? So, obviously if anyone has questions about assignments 1A or 1B, happy to answer them up here. Once we get done with that, we're going to get into creating custom classes, so defining and implementing your own Objective-C classes. We're going to talk about object lifecycle, creating, destroying, everything that happens in between. Auto-release, what auto-release is and why it's useful. And finally, Objective-C properties, because these are tied in pretty closely with designing and implementing your own class. So any assignment 1 questions before we dive into things? Yeah?
Were we supposed to worry about garbage collection?
Right, so the question was, for assignment 1, are we concerned about memory management, leaking memory, or what happens to memory after we've allocated it? For assignment 1, we don't care. Just as long as it works. We've suggested in the assignment to use the like for NS array or NS mutable array. There's an array method which creates an array for you to use. For assignment 1, that's all you need to know. We're going to talk a little bit, after today's lecture, you'll probably have a more thorough understanding of when you need to worry about managing memory, but no stress for 1. Any other questions? All right, let's get going with custom classes. So you'll probably remember from a couple of our last lectures, we've been talking about this person class in a lot of our examples. And today we're going to actually look at implementing that in code. So the class that we're going to create is person. The first thing you need to do is decide what the superclass of your class is going to be. In this case, there really isn't any extra behavior that we want to, get for free. So when in doubt, when you're not sure what else to subclass, you should subclass NSObject. As you'll recall from Monday, that's a kind of a good starting point. Includes a lot of common behavior that you'll need. If we were creating some sort of view on screen, maybe we would want to subclass UI view or UI control. There's all sorts of other cases where you might want to subclass another object. But for here, we're just starting with NSObject. We then want to ask, what properties should this class have? And if you remember the voting example, casting a ballot, the properties it's going to have are going to be a name, an age, whether or not they can vote, and then also actions that this class can perform. The one action we're going to look at here is casting a ballot. Real quick review of methods and selectors and messages, just to make sure we're all on the same page. As you're probably familiar with from other languages, a method is just a bit of behavior associated with an object, right? So here, this class has a couple of methods: a name method and a setName method. And the method is really, the behavior itself that occurs. Next is a selector. There's some questions about what exactly a selector is. Really, a selector is just a name. It's a way to refer to a method. It includes colons to indicate arguments, but what it doesn't include is any type information. It doesn't tell you what the return type is. It doesn't tell you what the types of the arguments are. It's a kind of generic way to say, hey, this is the thing that I want to call. So a selector, you can actually package up a selector and hold on to it. You don't even have to invoke it here. It's sort of like writing down somebody's phone number without actually calling them. Maybe later you'll call them. So here we're creating a selector for a name method. It takes no arguments. Who knows what the return type is? Another selector might be setName. As you can see from the colon, it's got one argument. A third selector might be do stuff with thing and thing. I love methods that are named like that. So as you can see here, it's got 3 arguments. So a selector is just a name for a method. And it can be conveniently used in Objective-C in some interesting ways. And finally, a message is actually the act of performing a selector on an object. So if a selector is a phone number, a message is the actual act of placing a phone call. It includes arguments, if it's a method that takes arguments. So here we're invoking a couple, we're sending messages to a couple of objects. First, we're sending the name. We're performing name on this object and getting a result back. And then we're sending setName with an argument. So does that sort of clear up methods, messages, selectors? You don't really need, we're not going to quiz you, at any point in the class. It's just sort of, something you should be more or less familiar with. So let's actually get into the creation of this class here. When you define a class, it's going to have 2 parts. There's going to be a public header, which you're probably familiar with from C programming. The file name will typically end in .h, and you'll have a private implementation. The reason it's .m instead of, you've probably seen .c or .cpp. If you just kind of say implementation, you're like implementation, it's an M sound. Whatever, it's .m will be Objective-C implementations. So let's look at the header file first. The class interface is going to be declared here, and you're going to use the keyword @interface to sort of signify that you're declaring a new class. The first thing you're going to do is say what object it's inheriting from. So the superclass, as we mentioned, is NSObject. In order to get NSObject is declared in the foundation framework, which we've talked about a little bit. So we're going to import foundation/foundation.h, and that gets us NSObject and a lot of other stuff in Foundation, NSArray, NSDictionary, all that good stuff. So by doing that, we've got enough information to then subclass NSObject. From here, we're going to have a couple of curly braces, and within those curly braces, we're going to declare any instance variables that instances of this class should have. So a person is going to have a name, it's going to have an age, and they're listed with both the name of the IVAR and the type. Yeah, question?
When should we use int versus something like NSInteger or?
Right. So the question was, when do we use int versus NSNumber, which is an Objective-C wrapper class for numbers? Typically, the main utility of a class like NSNumber, which wraps, say, an integer or a double or a Boolean or whatever, is for cases where you need to add that to a dictionary or an array that only takes NSObjects as the types of things that are stored in it. Most of the time, I mean, if you're just implementing this class here, it's going to be easier for you to interact with an integer, especially if you need to +1, -1, that sort of thing. You can just say age ++, rather than taking the NSNumber, unboxing it, updating the value, and then packaging it into an NSNumber. Does that make sense? Okay. Any other questions so far? So in addition to we've been hammering this in, we've got attributes or properties, and we've got behavior. So up at the top within the curly braces are instance variables, and then down below we've got some behavior associated with this. Yeah, question?
Are there any access modifiers?
We're going to talk about that in a little bit in terms of, yeah. Actually, we're not going to cover that today, but you can check it out in the docs. You can specify whether your instance variables are public, private, only accessible by, there's a keyword called package, which means other code within this framework can access this. Typically, you don't want people messing around with your IVARs. So your sort of instinct should be to use setters and getters. So here we've got this class. This is pretty much all we need in our interface file here. Yeah, we've got some methods declared. We've got some IVARs. We've got the superclass. We import foundation. So going back, now we've got to implement this in the implementation file. I'll stop doing that. So when we're implementing this custom class, we're going to implement those setter and getter methods, the set name and the name method, the set age and the age method, and also the action methods, which was, I think, cast ballot was the name of it. So first, let's look at implementing those setters and getters. This is within the .m, and first we're going to import person.h. Import is a lot like #include, which you've probably seen in C programming. Import just has some built-in smarts to avoid importing the same thing multiple times. You've probably seen this, sort of boilerplate code in C header files where it's like if ndef, whatever, def. It's the nice thing about import is it allows you to avoid that. And then again, we're going to use the @ symbol in the header. We used @ interface to declare the class interface. Here, this signifies that we're starting out with the implementation of the class. So we type @implementation person and @end down at the bottom to signify that we're done. And then in between here, we're gonna implement these methods. So as we've seen before, instance methods begin with a dash, pretty much the same as they were declared in the header, except instead of ending with a semicolon, we've got the curly braces and then the implementation of the method. So in this age method, which returns the age, we're just going to return our instance variable age. And in the setAge method, which takes an integer, and the name of it is going to be value, we assign value to age. Pretty simple stuff here. Any other methods will go in here as well. So these are pretty simple methods, but yeah.
Could you explain how the plus and minus is?
Yeah, so minus signifies that it's going to operate on an instance of the person class. So you've created a single person. Say the person is Troy. A method with minus in front is going to operate on Troy. A method with a plus in front of it is going to operate on the person class as a whole. So maybe the person class, let's say it keeps track of all the people that you've ever instantiated. So there might be some method, plus, it returns an NS array, and maybe it's called all people. So you wouldn't need an instance of a person object. You would just say, rather than saying, Troy set name, Troy name, or something like that, you would say, square brace, the name of the class, the person class, and then you would invoke the all people method on it. Does that kind of make sense?
Like static in Java.
Yeah, kind of like static. It's a method on the class as a whole, rather than instances of that class. Next, we're going to look at calling our own method. So we've implemented this age method and the setAge method. Let's say we want to implement can legally vote. And probably the easiest thing to do here is going to be to use the age that we've got. We could just access the IVAR directly. There are varying opinions on whether you should always use the setters and getters or whether it's okay to sidestep them sometimes. Here, just for the sake of illustration, we're going to call self-age and compare that to 18. So the key takeaway here is that when you're within the implementation of a class, you can call other methods that are also implemented on other instance methods by calling it on self. Then in the cast ballot method, we're going to say, if self can legally vote, call that method that we've just defined up above. And if we can legally vote, we do our voting stuff, whatever. So the takeaway here is that, so we have an implicit variable named self. And in other languages, it's called this oftentimes. It's a way of referring to methods on yourself. You can also invoke superclass methods. It's less common, but you can invoke superclass methods by calling them on super. And this is most often found when you need to build on some of the superclass functionality. So there's some method, do something, and we've decided, for whatever reason, we want to subclass it and extend it with our behavior. But we don't want to forget about the superclass behavior. So first we're going to call super, do something. Super is going to be the receiver of the message. And then we do our custom behavior, whatever it is. Does that make sense? Yeah?
Is the self required to call internal?
Yes, it is. Yeah. The question was, is self required to call methods on yourself from within your own implementation? Yeah, in some other languages, you can just kind of call the method. Here, you have to say self. There always has to be a receiver. There's never like an implicit sort of receiver there. Yeah?
You're calling a superclass method that you haven't subclassed. Can you still use self, or do you have to use super?
In that case, so let's say we're within do something, and our superclass has implemented another method called do something else, and we want to call that. You can just call self do something else. You don't necessarily need to call super. Right? Yeah, just call self do something else.
Super is just a disambiguation.
Yeah, exactly. If you're overriding it, if we were to call self do something right here, that would result in an infinite loop. We would just keep calling ourselves. Does that make sense? All right. So those are the basics of creating and defining our own class. Yeah, one question.
Is there any difference between interfaces and classes, or is it just terminology when you call it?
Difference between
Interfaces and classes.
well, an interface is the way of defining. It's like declaring the class, and then implementation is where the actual code of the class goes. So in some languages, Java, I believe, I haven't written much Java code in a while, but there isn't, it isn't necessarily separated out like that. Yeah, the reasoning here is that, oftentimes you'll expose the header file to clients to call, but you don't want them to see your implementation. If you look at the UIKit classes, for example, you can see all of the .h files. You don't see the .m files. Yeah.
Could you have different .m's for the same .h?
The question was, can you have different .m's for a single .h? You can. It's you would really only do that for the purposes of sort of organizing your code. Maybe you've got a bunch of code about one set of related behaviors and other code that's where you just kind of want to clean it up and make it so it's not a 10,000 line source file. But yeah, it's not as common, and certainly for the purposes of the assignments that we're doing right now, it's not something one-to-one typically. Yeah, it's pretty rare that you have multiple implementations. All right. So next we're going to talk about object lifecycle. And what I mean by object lifecycle, first of all, is creating objects, how we actually get an instance of an object. There's a couple of different ways to do it. We're then going to talk about memory management, the question we had at the beginning about assignment 1, how do we avoid leaking memory or over-releasing and crashing, and then destroying objects. What happens when, all good things must come to an end and all objects must be destroyed at some point unless they're going to leak and cause your iPhone to reboot. So let's look at object creation first. There are, in Objective-C, there are two, in Objective-C in Cocoa, there are two steps in creating an object. The first step is to allocate the memory, the space that's required for that object. Just sort of, blank out, stake some ground for this object to live in. The second step is actually to initialize, fill in the default values, maybe do some initial setup. So there's two methods you'll call here to do this. The first one, as you'll see from the plus, is a class method, and it's called alloc. You'll see this all over the place in Objective-C code. So alloc it's a class method that knows how much storage space is required by this class. So it'll basically go out and allocate some memory for you and return it. The second part is an instance method, which knows how to, like I said, set up the initial values and the initial state of that instance of the class. So the class method alloc stakes out the space, init lays down the initial values. So creating is allocating and then initializing. So if we're going to create a person, an instance of person, so we declare a person variable right here. We start that as nil. And then to initialize it, we'll call person alloc init. And as you've seen before, we can nest message invocations together. So we call person alloc, and then on the result of that, we call init. So the receiver of the first message is the person class. So that's the plus alloc. That returns a person instance, which we call init on. Does that make sense? Greg, did you have a question?
Oh yeah, I was playing with this yesterday, and I was able to get this to work by using the new command.
Mm-hmm.
So why are we saying alloc into when we could say?
Yeah, okay, that's a good question. We're not really going to be covering new today, but there is a sort of shortcut to alloc init. There's a method called new, which basically it just does alloc init. You end up typing a little bit less, but I think the reason it's not terribly commonly used in Objective-C code. I think the reason is that a lot of the time you'll have, rather than just calling init, you'll have some custom constructor, which we're actually going to talk about in the next slide. But there'll be a lot of places where you're not just calling init. You're calling init with objects, or init with person, or init with string, or something like that. So rather than having some code which says new and some code which says init with whatever, just for consistency's sake, I think a lot of people just lean towards calling alloc init. And it's a pretty common idiom to see. Does that make sense?
Yeah.
Okay.
Second question is we're using the brackets here,
Mhm.
so can we use the dots? Maybe that might look a little better.
The question is, can we use the dots here, the dot notation? I wouldn't. It would probably, start to feel like a, I mean, we're going to talk more about the dot syntax later today, but typically it sort of feels right to use the dot syntax when you're accessing a property like name. So if saying person dot name instead of bracket person space name bracket, I mean that sort of, you read it and you understand what it's trying to do. To say person dot init, it would feel a little weird, at least to me. It would probably work, but it's just kind of a matter of common convention and style. Did you have a question?
Yeah, what does person alloc return?
Person alloc returns, it returns a person instance, but that person instance has not had really anything done to it yet. It's not really ready to receive messages or anything like that. I guess so, yeah. That's a good question, actually. So next we're going to actually talk about implementing our own init method. So in some cases, you're going to want to have a custom method which takes a couple parameters and gets things set up in a default state. So maybe in person we want to override init. The first thing you're going to do, and this is just common convention Objective-C, is you're going to call super init. So whatever init type stuff NSObject does, which is our superclass, is going to happen. Now, the reason we're saying we're assigning that back to self, really, this is not something you need to worry about too much. There are some very, very rare cases where calling init might actually return a different object. This hardly ever happens, but just on the off chance that there's some class which is like maybe doing some uniquing, or it's already got an instance that it wants to give to you, you generally assign the result of super init to self. If you didn't do this, probably most of your code would work correctly, but maybe in the future something gets changed and NSArray decides to return a different instance in the init method, and then you're kind of hosed in your code. So, follow the pattern and just kind of do it. Yeah, question?
Is equals a Boolean and an assignment in this?
In this case, it's going to assign, and it's going to return true if self is non-nil. So basically, a different way of writing this, which I actually tend to follow, is in the line above the if, just say self equals super init. And then you can say if self, curly brace, do your additional setup in there. Does that make sense? Yeah.
If that actually changed the value itself, wouldn't that cause a memory leak after the malloc?
The super class would need to release the memory, and yeah, you can see why it doesn't happen very often. All right. So then inside here, inside the curly braces, once we know, again, this is totally defensive programming. We're going to set up our initial value. So maybe age, we want to explicitly say age starts out at 0. The name, we want our people to all be named Bob unless we name them otherwise. Doing any other initialization, we can call methods in here. We can set instance variable values. Yeah.
I guess what would be the right way to handle that error if it didn't return self?
If it didn't return self, it's not necessarily an error. I mean, it would be an error if it returned nil, because then somebody is saying like, hey, something bad happened. Don't try and assign instance variables because we weren't able to, because things just went wrong. Really, I mean, I've never had to write any code where I had to worry about self being assigned some other value. It's just sort of like one of those things where I have to tell you, this might happen just so that you don't, get mad at me later if it does.
So to be clear, if self is the same as if self is not equal to null.
Yeah,
or nil.
yeah, exactly.
Could you give an example of?
Oh, sorry, I didn't repeat that question. This little bit of code right here, self equals super init, is the same thing as assigning above and then checking whether self is non-nil. That's for you guys. Yeah.
Could you give an example of this code giving an error without the self super int stuff? 'Cause
Right.
I know you can do this without calling that, so I'm not clear about the case in which it.
So you're asking about an error in initialization.
Yeah, like I'm not convinced that I need to have this line if self equals super int.
Well, you need to call super init
Yeah.
to initialize, to do whatever super initialization happens. If you want to talk more about assigning to self, we can talk about that offline. Is that cool? All right. All right, let's keep a move on. So you can have multiple init methods. The catch is that they need to be named differently because there's no overloading. You can't, they need to be named uniquely. Yeah. So here maybe we'll have an init method which uses some default name and age. We could have an init with name method which takes a name and uses the default age. And then we could have the most specific, an init method that takes 2 arguments. And what you'll often do here inside your implementation is that the less specific ones will call the more specific ones with whatever the default values are. So our implementation of init might actually just under the hood be a wrapper and call init with name, no name. I guess it should have been Bob if we were going to stick with the Bob thing. Init with name, in turn, it just passes things along to the most specific init with name age method, and it passes in the default age. The nice thing here is that you don't end up re-implementing the entirety of your initialization method 3 times. You can sort of get them all into a single funnel point where you do all of your setup because copying and pasting code is something you don't want to do. We cool here? Yeah. Oh, sorry.
The ID identifier, what does that mean again?
ID is a generic object. It's close to, but not exactly the same as saying NSObject star. It's a way of using sort of loose typing, saying, hey, this is an object. I'm going to call some methods on it. I'm not going to be too specific about what it is. The reason we tend to use ID as the return type for initialization methods is because when you subclass, you would then be in a situation where the types don't match up. So the pattern that you'll typically see is that an init method returns ID, so that if you subclass it, things don't get too complicated. We good?
Yep.
All right. Yeah. Oh yeah.
So if you use NSObject pointer, then we can't. If you try to use that in place of ID, then we cannot access methods that NSObject doesn't have access to.
So the question was, if you have an NSObject pointer rather than an ID, can you access methods that aren't defined on NSObject? You can. You'll get a compiler warning. The compiler will say, hey, you're calling this method. As far as I know, this is an NSObject instance, and this method is not defined on NSObject. So what you would need to do there would be to typecast, parentheses, before the variable name. The nice thing about ID is that you're basically saying, you know, be loose about the type checking here. As long as this method is defined someplace, let me call it. So I mean, ID is most useful when you're referring to something that's already been created. You'll never create something that's an ID. I mean, it's got to be created with a specific type. It's sort of later, if I don't care whether this thing is an NS button or a UI button or a UI slider, and I just want to call some method on it, it makes my code a little cleaner. Was there one more question? Sorry?
What's the difference between ID and like a void star?
So the question was, what's the difference between an ID and a void star? They're basically the same thing, except I believe ID is typecast already as an Objective-C object. So it's just sort of a convenience. And then we're going to finish up with this object. So we declare a person variable. We allocate some space for it. We initialize it. We do some stuff to it. So we got Alec Canestraro here. We call some methods on him. We tell him to cast his ballot. And then what do we do when we're done? We don't just want this memory to sit around in space once we're done with it. Thinking back to C programming, which I'm sure most of you are familiar with, in C, there are sort of counterpart methods. There's malloc to allocate some memory. There's a couple of other methods, but malloc is one that we typically refer to. And then free, tells the system, hey, you can start to use this for other purposes. In Objective-C, we have similar sort of counterpart methods. We've got alloc, which, as we mentioned, stakes out the space for this object. And then dealloc is the counterpart, where everything gets torn down. The calls must be balanced here. If things, just as, has anyone ever written some C code where you called free and then you freed that same block of memory again? Anyone know what happens there? Probably depends on your system, but you might get a warning message. You might get a crash. It's generally a bad thing. Same thing here. So these calls need to be balanced. One important thing, though, is that you're never going to call dealloc directly. So when you're done with an object, you're not going to trash it by saying object dealloc. There is one exception where you do actually invoke dealloc. We're going to talk about that in a little bit. So if you don't actually call dealloc directly, how do objects get destroyed? It's via a mechanism called reference counting. And the deal with reference counting is that every object has a retain count. It's basically a count of the number of times someone else has said, hey, I'm interested in this object and I don't want it to go away for the time being. Does that make sense? So the retain count is defined on NS object. This is another sort of built-in bit of behavior. And as long as the retain count is greater than 0, then your object is alive and well. You can call methods on it. Alloc, and there's another method called copy, where you can say you've got a string and you want to copy the string. Both of these methods will create objects with a retain count of 1. So it starts out, alive, well. You need to specifically say, hey, it's time for this object to go away before it'll go away. There's a method called retain, which anyone can call on an object, which will increment the retain count by 1. Then on the flip side, release will decrement the retain count by 1. So as you're starting to probably guess here, you need to balance your calls to retain and release. Otherwise, you're either going to leak memory or you're going to over-release, which will typically cause a crash. So as I mentioned, when the retain count reaches 0, the object is destroyed. And this sort of NS object machinery will automatically call the dealloc method on this instance for you. So really, all you need to worry about is calling retain and release in appropriate combinations. And when you're in dealloc, just as a side note, it's a one-way street. You can't bring the object back from the dead when it's already being, buried. Yeah, okay. So you can't, retain the object within dealloc. That's typically a bad thing to do. So we want to balance our calls here. We allocate this person. By calling alloc here, the retain count is 1. We do our stuff to the person. And then when we're done with it, we call person release. And this release call balances out the alloc up above, and the person will be destroyed here. If maybe in the middle, for some reason, I called retain, I'll need to balance that out with an additional call to release. Make sense? Any questions? Yeah, sorry, I need to look this.
If I have an object pointer and if I just make that object pointer point to this object that I've already created, then if that does not implicitly cause the retain method.
That's correct.
And I'll have dangling references.
So the question was, if I have a reference to an object and I assign that to another variable, will that implicitly call retain on it? And the answer to that is no. You need to call retain yourself. So if you do that, if you assign a variable to another variable without calling retain, it's possible that whoever else is retaining it might let go, and then you're left with this stale pointer. The danger there, we're actually going to talk about in a little bit what might happen in that situation. Is there another question? Same question? Okay. All right. So reference counting in action. You've probably all got this by this point, but I just wanted to hammer the point home. We allocate this person, we call alloc, and whenever you see alloc, your eyes should light up and you'll think, this thing has a retain count of 1. And then later in some code, we retain it because we want to make sure that whatever we're doing here, maybe it takes a while, maybe maybe it takes a while. We call retain, and the retain count gets increased to 2. Later, we're done with it in that code. We call release. It gets decremented by 1. It's now at 1. And finally, later, whoever created it is all done with it. Retain count goes to 0. Dealloc will be automatically called. You don't call dealloc directly here. Yeah.
Why would you want to say retain? Isn't it fine how it is?
Right. So the question is, why am I saying retain here? This is kind of for the purposes of just fitting something on a slide. You wouldn't really need to call retain immediately after calling alloc init. This would be more common if you had an instance variable where this instance variable needed to remain valid for some period of time. That makes sense? Yeah, this is you're not going to see code like this probably ever where you're just calling retain, 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 release, release, release. It's usually longer periods. Yeah?
So since it's not going to be deallocated until you call release,
Uh-huh.
why would you ever call retain to make it more than 1?
We'll see an example of that in a little bit. That's a good question. The question was, if it's not going to be deallocated until you call release to match the initial alloc, why would you ever call retain in additional places? The short answer there is that maybe there are multiple objects interested in this one object. So they all say, hey, I want to retain this, I want to retain this, I want to retain this. And then maybe the first one who created it says, okay, I'm done, I don't care anymore, release. The other objects which have also, gained references to this object, they don't want to be left with stale memory. Yeah?
So if you dealloc instead of release there, it just goes away?
You're asking what would happen if you called dealloc directly?
Yeah.
I'm not even going to attempt to answer that. I'm not sure. What would probably happen is you would call, the question is what happens if I called dealloc directly here? Probably you would run through dealloc, and then later this object might get released again, and then dealloc would be called again, and it's just a kind of, you're in undefined territory when that happens. So easiest answer is to not do it. Unless you're curious. Maybe Troy will show you what happens when you just call dealloc a bunch during the debugging seminar. So there were some questions about messaging deallocated objects. So let's say we create this object, we do some stuff with it, it's released, and then we try and we send a message to it later. Let's say some time has gone by. Odds are what's happened here is maybe some other code has jumped in and used this memory which was freed, because once it gets deallocated, that heap memory can then be used in other places in your program. So there might be nothing there. There might be some other object there. There might be random garbage memory because your user just downloaded an email message, and that email message is partly in that space in memory. Whatever happens here, it's probably gonna be very unpredictable. More often than not, you'll crash. Maybe more insidiously, maybe nothing will happen, and you won't even realize. And then you'll ship this app out to a customer, and they'll run across some set of data which causes it to crash. These are very, very difficult problems to debug. One easy way to avoid that is when you're done, set your local variable or whatever the variable is to nil. So that way, if you then call do something, you'll at least just do nothing, right? Because messaging nil is okay in Objective-C. The effect is basically a no-op. So if you're gonna have this variable around after you know that you've released it, it's typically good practice just to nil it out, especially if you've got like complicated branching logic where sometimes it gets released, sometimes it doesn't, and then you want to do something with it at the end if it's still around. That's a great situation to call nil when you've released it. Yeah.
But then if you have other instances which returned
Mm-hmm.
and you set it to nil, then do the other instances have access?
That's a good question. So what if other other bits of code have retained this object? Setting the variable to nil here will not affect anyone else. So this is just if you think about it just in straight C terms, this is a pointer that I have here. I've been doing some things based on this pointer, and then I reset this pointer to 0. If somebody else has their own pointer, it's its own stack or instance variable, it's pointing at 0x8b3 whatever. That pointer is still nilling out this pointer does not nil out the other pointer. Is that cool? Was there a question back there someplace? No, I thought I saw like a. All right. So when in doubt, nil it out when you're done with it. Would be the Cliff Notes version. One other interesting bit here is, there might be a situation where you want to do cleanup in Dialog on top of whatever the super implementation does. The way this will typically look, and we haven't really gotten into the reasons why you might do this, but you'll override the Dialog method. This is in our person class again. You'll do any cleanup that you need to do, and then you'll call super Dialog. This is the one place where you will be sitting down in front of your computer and typing, and you'll type DEALLOC close square brace. Okay, you should never call it anyplace else, but you do need to call super Dialog if you implement your own Dialog method. Does that make sense? Yes. Okay. So a quick recap here: objects begin with a retain count of 1. You can increase and decrease by calling retain and release. When the retain count reaches 0, the object will be deallocated automatically. And never call Dialog unless you're calling super Dialog. Now let's talk a little bit about object ownership. And this sort of starts to bring us to cases where it's not as simple as just a single method where we're calling retain and release and we're done with it. If we've got this person object here and it's got a name, name is an NS string, and we don't want this thing to go away. Maybe some other piece of code has created this person, and they've set the name, and then they've released that string after creating the person or after setting the value on the person. We want to make sure that we've got a valid NS string reference here, otherwise bad things might happen later on. So what we're going to need to do within the implementation of set name, NS string name obviously just returns name. In the set name method, we're going to need to retain it, to bump up the retain count by 1, so that even if somebody else releases it, the original creator, we've still got it and it's still valid. So this is a common sort of idiom you'll see here. Obviously, if you're trying to set it to something that the value and it already is that value, you don't really need to do anything here. The other reason we're checking for equality here is that if we didn't have that line, imagine that the if name doesn't equal new name was not there. So let's say name was already set to some value, and then we set it with that value again. This first line here, where we release before we retain, there's a chance that might bump it down to 0, deallocate it, and then we try and retain it again. So it's just sort of a way of preventing a sort of edge case where we might accidentally, blow away this object when we don't really want to. So we release our old value for the instance variable, we retain the new one, and assign it to our ivar. So this is something you'll see in a lot of places in Objective-C code. Does this make sense? So basically, what's happening here on a very high level is that the person is taking ownership, or at least shared custody of this NS string. Does that make sense? Any questions? Yeah.
Does that also mean, though, that somebody else might change the contents of that out from under you?
So that's a good question. The question was, does that mean someone else can change the contents out underneath you? And that actually takes us back to a big part of why NS string, NS array, NS dictionary, by default, these are immutable objects. And if you remember from Al's lecture, a lot of these objects come in mutable and immutable variants. It makes it a lot easier to manage your code if these things are immutable. You create them once, and then if you need to change something about it, maybe you make a copy, a mutable copy, and then you can do things to it. You can append. That's why the NS string, append string, rather than modifying the string that you've got, it returns a new string. So that's one advantage of having this distinction between mutable and immutable objects. The other big reason that we're going to talk about later this quarter is going to be in cases of threading. And this is, becomes even more obvious. You've got this string or an array, and if it's mutable and you've got multiple threads all trying to do things to it, you've got to put in a bunch of locks to keep it from getting, left in a half initialized state by one thread, and another thread tries to read it. You've all heard about these types of problems in CS 107 probably. So that's another sort of nicety of having this mutable, immutable distinction. Does that make sense? Okay. What am I doing here? Yeah. Oh, another way to do it here, I mentioned the copy method. So let me take a step back here. You can call, release and then retain the value that was passed in. Or if you really want to make sure, like we were saying here, that nobody else does anything to this object, you can call copy instead. And just like alloc, copy will return a new object with a retain count of 1. So strings are a case where you'll often see copy used instead of retain, just because the author of the code is being a little paranoid and wants to make sure that nobody else is messing with this string underneath the hood. Does that make sense? Those two implementations, release and then copy, and then release and then retain, are basically equivalent from a memory management standpoint. So then we need to release these instance variables at some point. And this again takes us back to a case where it isn't just a single method. We don't necessarily know how much time has elapsed between the initial creation of this object and our retain and somebody else's release and then our release of the object. So in our dealloc method, we were talking about overriding dealloc. The type of cleanup that we might need to do here, if we've got a retained instance variable, is to call release on that IVAR. And that makes certain that when the person goes away, if it had ownership or shared ownership of this string, maybe other people own it, but at least from our point of view, we retained it, we need to balance that out with a release. So you'll see that very, very, very often in your dealloc method override. And then we just call super dealloc like we normally do. Does this make sense right here? It's pretty important to have a handle on. Just remember that calls to retain and release need to be balanced. So if you retain something in a setter, you'll need to release it at some point, and the point of last resort is dealloc. Yeah?
Instead of super dealloc, can you do self-release?
The question was, instead of super dealloc, could you call self-release? What that'll probably do is, at that point your retain count is at 0, and it'll try to take the retain count to, -1. I'm not sure off the top of my head what would happen there. It's bad, whatever it is. And that's something you can try out in the debugger and sort of see what happens. But it's probably not going to be what you want. That's a good question. It's good to think about. Any other questions? All right. And now, auto-release. Auto-release is awesome. So the deal, here, let me present a problem to you first, and we're going to try and, and then we'll see why auto-release is a solution. Let's say we've got this method. It's called full name. And say in this person object, we've got a first name and we've got a last name. And this full name method, what it's going to do is it's going to concatenate these two strings together into this new string. It's going to call alloc, init with format, with the first name and the last name, and then it's going to return it. What's the problem with this code right here? Can anyone see? Yes, Troy. So, well, it never gets released, right? So we're calling alloc. Basically, what we're assuming here is that whoever's calling this method somehow knows that they're getting a retained object, and they need to call release on it. And we've all probably seen code where those responsibilities are not clear, and you don't release it because you didn't think you had to. So the result here is that it leaks, or at least there's the possibility of a leakage if there's not good communication between the API creator and the API consumer. So another option here is to call release. What's the problem here? You're giving them some bogus value back that's been deallocated, and remember, deallocation is a one-way street. You can't go in and resuscitate it. So the problem here is it's released too early. We're returning a value that's already been deallocated. So what we really want here, at least one possible solution here, is to call this method called auto release. This is Goldilocks, just right. It'll be released, but not right away. I'm going to explain what that means later. But basically, the idea here is you've balanced out your calls. You called alloc and you called auto release, which is basically equivalent to release. The caller gets a valid object back, and then if they want to hold on to it, they can call retain, and it's not too late to save it from being deallocated. So to keep this problem in mind as we're talking about the solution, which is auto release. Auto releasing basically flags an object as needing a release call at some time in the future. So it lets you fulfill your retain release, matching up these calls, your obligation to do that without necessarily getting rid of things right away. So it makes it much more convenient to manage memory when you're not entirely sure about how long this object needs to stick around for. And like we just saw, it's really useful in methods where you want to return a newly created object, but not have it necessarily be the caller's responsibility to release it. Let's imagine that full name method, anyone who called it was required to release the result. So if you were calling that method a lot, you'd just be calling, person full name release, person full name release, especially if you're calling this thing, repeatedly. So in terms of negotiating, what returns an auto-released object and what doesn't, the rule of thumb here is that if the method has alloc or copy in its name, it returns something that the caller needs to release, either by calling regular old release or auto release. Greg also mentioned, I was waffling on whether to put this in the slide. New is another sort of keyword where if new is in the method name, it returns an object with retain count of 1, and you need to release it. So here we create this mutable string, and its mutable string alloc in it. And at this point, we as the callers are responsible for releasing it somehow, either via release or auto release. Any other method out there, and if this is not true, then whoever wrote the method is not really following the convention, returns an auto-released object. So if instead we call NSMutable string, which some of you have probably called in, well, maybe not, yeah, you probably have called that in assignment 1B. And this is why in assignment 1B you didn't really have to worry about memory management if you were calling NSMutable string. It doesn't have alloc, doesn't have copy, doesn't have new in the name. You're not retaining it, so you don't need to release it. This returns an auto-released object. We're all good. Make sense? So this is a convention. There aren't any rules about this necessarily, but if you don't follow the convention, you're going to end up with some code that follows it and some code that doesn't, and whoever works on this code with you is probably going to hate you. Yes, question?
Do you create a normal NS string with that at quote
Uh-huh.
syntax?
Yeah.
Doing the second first way, right? Is it already auto-released?
That's kind of a special case, and actually someone asked me a question about, the question was what happens when you create a string using the at quote, basically a literal NS string. And somebody asked me about that last class, and I didn't have a great answer, and I was going to look it up a little bit, and then I forgot to. The short answer is that you don't need to worry about memory management with a string literal, an at quote, whatever. Just keeping in mind, you didn't call alloc, you didn't call, maybe you might call retain at some point, but just by virtue of creating it, you don't need to worry about it from a memory management standpoint. There's more, under the hood, there's some fancy behavior that's going on. If you've got, multiple instances of the same string literal in your application, those will actually, when it gets built, those will get mapped into the same string that's in memory, which you can't actually modify. But that's kind of neither here nor there. So short answer is you don't need to worry about releasing it. Yeah?
So when does it get deleted, the auto-release version?
That's a great question. I'm going to tell you about that right now. Well, maybe not this slide. Maybe the next slide. I can't quite remember. Auto-release is magic. Just remember this. You'll be all good. Okay. Auto-release actually works by adding the auto-released object to this thing called the auto-release pool. Why it's called a pool, I don't know. The auto-release pool basically tracks a list of objects that it needs to send release to at some point. And when the pool itself is released, it'll go through its list of objects and it'll say release, 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 release. UIKit, and this is where auto release pools will typically get created. UIKit will automatically create an auto release pool at the beginning of every event dispatch and then release it at the end of every event dispatch. So it's actually very, well, not very, but it's pretty rare that you'll create your own auto release pool. So let's talk about a little bit more about when exactly this whole event dispatch thing is happening. So here's sort of not the object lifecycle, but the app lifecycle. You know, down here in the lower left, you're launching the app. The app gets initialized, you load the main interface builder file, and then you sort of enter this loop. It's called the run loop or the event loop. And this is where sort of all the processing in your application happens. Your app is waiting for touches from the user. It's waiting for network traffic. It's maybe waiting for timers to fire if you set up an NS timer. It's just waiting for events to come in, and then it's processing those events. Eventually, at some point, you know, your user hits the home button, and your app will get a message to terminate. But for the majority of its existence, your app is spinning around in here. So at this point, your application, UIKit actually, will automatically create an auto-release pool. And any object auto-released during that cycle will go into that pool, which was just created. So you create an object, you call auto-release, it hops in the pool. Create another object, you auto-release that one, it hops in the pool as well. Create a third object, they're all hanging out in the pool. And then the pool will get released, again, automatically by UIKit. And at this point, we're going to call, the auto-release pool is going to call release on each of these objects that are swimming, waiting, whatever, in the pool. And they will be released. If that's their last, you know, if their retain count just went to 0, they'll go away. So what it really means is that when you auto-release an object, typically it means it'll stay around for a while. It'll stay around long enough for you to do other things with it. But at some point, not too far down the road, it's not going to be like 5 minutes. It'll be, you know, in the order of, you know, microseconds. But it'll stay around longer for you to do other stuff with it. Or maybe, you know, like we said, if we return an auto-released object from a method and then immediately retain it, will be cool. We will have bumped it back up to 1 before the auto-release pool, you know, got the plug pulled on it. Yeah, question?
Does it work well with threading?
Does it work well with threading? So every thread, that's a good question. Every thread needs its own auto-release pool. So that's kind of how that works. We'll talk about that a little bit more when we start actually using threads. But generally, when you create a thread, you're going to need to create an auto-release pool to go with it. Otherwise, you'll see messages on the command line where it'll say, object blah, blah, blah was auto-released with no pool in place, just leaking. I'm certain that the last 2 words of the error message are just leaking. Yeah?
Can you manually flush a pool?
The question was, can you manually flush a pool? The answer is yes. There are some situations that we're actually going to talk about that later in the quarter for performance reasons. Maybe you're in a tight loop, you're going over it 10,000 times, and you're generating a bunch of auto-released objects. And those things, you know, obviously they're not going away right away. So there are cases where maybe you use a performance tool, you find that your memory is ballooning when you're processing, you know, 10,000 email messages that you just downloaded or something like that. So there are situations there where you might want to empty out the pool. And we can talk a little bit more about that later in the quarter. All right, so we're getting auto-release pools here. It's kind of a, you know, slightly tricky concept to throw at you right after getting, you know, retain release. But it's important. You see it in a lot of places in code. You've already been using it in assignment 1 without necessarily realizing it. If you look at the code that's in your assignment 1B, you'll see in there there's actually code, because it's a command line tool, it doesn't have a run loop where it's automatically waiting for touches and stuff. You'll see in the boilerplate code that you got from Xcode, it actually creates an auto-release pool at the beginning and then releases it at the end. So you've got a single auto-release pool in your foundation tool. Yeah, question?
Should the guideline then be that if your objects are too big or take too much time to deallocate, then you should probably not put in that?
Maybe, yeah. So the question was, you know, if your objects are too numerous or too large to, you know, be dealt with effectively, if it's going to adversely affect your program to have them waiting for the auto-release pool to empty, you might want to use regular release instead. The tricky bit is that you don't necessarily know if there's other bits of code that are maybe calling auto-release on it. So it can be a little tricky. But yeah, that definitely can be, it's rare, I mean, but there are times when it can be a performance issue. You know, it's not the first thing. I wouldn't recommend you go into your iPhone app and, never use auto release because it'll hurt your performance. I mean, it's very useful, and there are targeted situations where you might want to not use it. So yeah, hanging on to an auto-released object. As we saw before, many methods return auto-released objects. Remember the naming conventions. And they're hanging out in the pool and will get released later. So if you need that object to persist, like maybe you want to keep it around as an instance variable, and your object is going to be living long past the turn of the event loop, then you need to retain it. Bump up the retain count before the auto-release pool empties. Make sense? It'll be more concrete when you actually use it, but just want to make sure you kind of know what's going on. So here is an example. We called NSMutable string returns an auto-released object. We want name to remain valid, so we call retain. Eventually, an hour down the road, we're done playing our iPhone, game, whatever it is. We call release on that name. One side note about auto-release. Auto-release is not garbage collection. The Objective-C runtime on iPhone OS does not currently have garbage collection. It was just introduced recently on the macOS 10 desktop. So we're not talking about Java here. Auto-release is not garbage collection. Just want to make sure you're not confused about what actually is going on. There are distinctions here. You still need to think about memory management, retain release. Obviously, it's better than needing to call malloc and free at the perfect points in your program's execution. But it's not all being done for you. So keep that in mind. One last little topic that I'd like to cover today is Objective-C properties. This kind of ties in nicely with the fact that we have been implementing this person class, which has age and name, which both have setters and getters. And you'll find you probably started to get a hint of it as we were implementing those methods. But it's kind of repetitive to type, okay, void, set name, and a string, name, over and over, 2 methods for every sort of property that this class has. And likewise in the implementation file, writing if new string doesn't equal string, curly brace, retain, release, it gets old after a while. So properties are an addition, part of Objective-C 2.0, which both make it more, you can declare these sorts of things by writing less code, and you can implement them in really common ways by also writing less code. So they're a shortcut to implementing getters and setters, and they also allow you to specify sort of the read-only versus read-write, or the retain-release semantics. You can say, okay, this property, whenever you set it, it's going to be retained, internally, or it's going to be copied, or nothing at all is going to happen to it. It's going to be just assigned. So let's look at actually defining properties. Here's our person header. This is the .h again. And right here we've got our method declarations. And like I said, it's starting to feel like kind of a lot of code for a pretty simple concept. We've got name, we've got age, and we've got can legally vote. So really these are the 3 things we care about here. So rather than having setters and getters for each of them, or even can legally vote, which is just a getter, but maybe there's a better way to denote this in the header as well. We can actually write it as property declarations. We use the @ symbol again, and we would say @ property, write the type. In this case, it's an integer for the age. The name is an NS string. Can legally vote is a Boolean. And then optionally in parentheses right before, we can say, this property is copied rather than retained or assigned. Or this property can legally vote. Remember, there was just a getter. There wasn't a setter. So this is read-only. You can't say person.canlegally vote equals yes. You can't hack the US voting system, or can you? So you can specify some interesting attributes of these properties. So this is what it looks like in the header. Let's look in the implementation file now. And again, age, set age, name, set name. Who wants to write this? You've got better things to do with your time. You've got shaking algorithms to implement, and flashlight to-do list apps. So all this code is really not that interesting. Sometimes it is, but most of the time it's not. So on the implementation side, again, we've got age and we've got name here. We can trim that down to just saying synthesize age, synthesize name. can legally vote, we still need to write a little bit of code for it because there really isn't a way to tell the compiler, like, this is what can legally vote means. The nice thing is that you can mix these sort of explicit implementations, like can legally vote, with synthesized, predictable, set the instance variable to the new value that just came in. And you can sort of mix and match here. Did we cover everything we need to cover there? Yeah, I think so. So what's going on here, actually, the age property is going to default to, if we look back here, age is going to be stored. The age property is going to map to the age instance variable. Because they have the same name, you can just write @synthesize age or @synthesize name. Let's do that again. All gone. So yeah, the attributes, we sort of mentioned them a little bit, but read only, it'll keep somebody from trying to set this value. You can set up the memory management policies here. So assign would just assign the value. It wouldn't retain the NS string. That means if somebody else releases it, you might be left with the stale reference. Maybe that's what you want. I don't know. You can retain. You can copy. Copy is probably most interesting. The reason why, and this just occurred to me, I should have mentioned it before. The reason why even though this is declared as an NS string here, you might want to declare it as a copy property because someone might pass in an NS mutable string, right? Because of the way inheritance works, if there's a method that takes an NS string, maybe some client, they created an NS mutable string and they passed it to you. And then they, as far as you're concerned, it's a string, but the other creator, whoever created that string, can then go in and change it under the hood. So if you really want to be sure that no one else is changing this string when you're not expecting it to be changed, that's why you would call copy versus just retain. Does that make sense? So there are cases where you might be expecting a string and it's actually a mutable string, so you want to ensure that it's really your own copy and you've got sole ownership. If you want, in our example before, we were mapping from the age property to the age instance variable and from the name property to the name instance variable. If you want, you can have different names here. In this case, our IVAR is number of years old. We weren't feeling particularly concise that day. But the property is age because that's what we're exposing to our client. So what you can do, rather than just saying synthesize age, which assumes the same name for both, you can say @synthesize age equals instance variable name. So in this case, number of years old. So you can get kind of fancy and, I don't know, yeah, whatever aesthetic reasons you might want to do this for. Any questions about that? And as I mentioned, you can mix and match, synthesized and non-synthesized properties. So, obviously we saw can legally vote, that was declared as a property, and we didn't synthesize anything about that one. We just implemented it ourselves because it was all custom logic. If we want to here, we can actually mix and match within a single property. Maybe for some reason in setAge, we don't just want to use the synthesized implementation. We want to set the age, and maybe we want to blast a notification out, or we want to ping some website and say, hey, he just changed his age, or something like that. So what I can do here is by typing synthesize age, I get the default. The compiler will give me a default implementation of the setter and the getter, unless I've already got an explicit setter in here. Does that make sense? This is sort of why I might synthesize it, but then have a custom setter anyways. There might be some additional logic that you want to layer on top of the default implementation. It'll make more sense when you actually come across a situation where you need to do it. Properties in practice. So the places where you're going to see properties, typically properties were a fairly recent addition to Objective-C. So if you look in the foundation framework, you're going to see very few properties declared in headers. Now that doesn't keep you from using the dot syntax in a lot of places. Properties and dot syntax, they're related, but they're not. You don't need to have properties in order to use dot syntax. So older APIs will tend to just use getter and setter methods. Newer stuff will tend to use app_property. UIKit, you'll see a lot of app_property declared all over the place. Not so much within Foundation. And then in code that you're writing, you can use either approach. If you need to implement some class, like maybe, for example, a Polygon class, which is in assignment 2, you can choose to use properties and synthesized implementations if you want to. It's a judgment call. You write less code, but maybe there are cases where you actually need to do custom behavior in addition to just setting the IVAR. Or maybe you just want to be more clear to whoever's looking at your code about what's happening. So you don't have to use one or the other necessarily. Does that make sense? Couple of comments about dot syntax as it relates to self and properties. Oh, okay, cool. When you're in a method within the implementation of a class, you need to be careful with dot syntax. If we've got both name as an instance variable and name as a property, setting name to Fred is going to be different from setting self.name to Fred. Do you guys see what the difference is here? Can anyone explain it? I saw a head nod.
Comment describes it.
Oh, yeah, I guess so. Right. Yeah. Huh. I didn't look that far to my right. Yeah, so the first line here is just going to set the IVAR. If there's any other behavior in the setter that we're expecting to have happen, like maybe send a notification to some other object, that's not going to happen. Calling self.name equals Fred is going to go through the set name method, and whatever logic is inside there is going to get executed. Does that make sense? So the top line is much more raw, and it basically does exactly what it says, and the bottom one will actually go through the setter. But it can be a little, especially if you're coming from other languages where those two lines are basically equivalent, it can sometimes catch you up, or trip you up, is what I was going to say. One other common pitfall about dot syntax is this little bit of code right here. We've got set age, and within there we're saying self.age equals new age. And again, maybe you're coming from a language where that line of code just assigns it to the IVAR. What's really happening here is self.age with dot syntax is equivalent to saying bracket self set age colon whatever. So what's that going to do? Infinite loop. We love infinite loops. We work for Apple at one infinite loop. So yeah, that's probably not what you want right there. If you're actually implementing the setAge method, then you probably want to just access the instance variable directly. But it can be tricky sometimes. And I've written code like this before and cursed at the computer and said that I hate properties. But then I was back using them and they saved me a lot of code. So, or properties and dot syntax, and the two are often, combined.
Is that only with properties?
Is that only with properties? Well, no, it's not only with properties. There are cases where you might say self dot whatever equals whatever. The compiler will allow you typically to use that even if it's not declared explicitly as a property. You can use dot syntax a lot of times in cases where it isn't declared as a property.
There's always implicit setters, basically.
Basically, yeah. Implicit setters or getters, yeah. Yeah, I mean, dot syntax is from the client side calling these methods, and properties, really what properties do is on the implementation side, they save you from writing a little bit of code in the header and in the implementation file. But, it's two sides of the same coin, defining and implementing these things versus actually calling them. So, yeah, question?
So dot syntax is never referring to an IVAR, is that right?
Dot syntax is, that's correct, never referring to an IVAR.
You refer to a property or a method.
Yeah, I mean, there might be cases like Greg mentioned, the question was, is dot syntax always referring to a property and never to an IVAR? The answer to that is yes. It may be referring to a property or some method which you've opted to use the dot syntax with. But then if you turn in an assignment where you've written, person alloc dot init, we might write in your comments like, hey, you're trying to be a little too fancy here. It's not really, init isn't really a property, it's like an action that's being performed. Yeah, question?
If you synthesize your Yosen setters to use the copy syntax, do you have to worry about then decrementing the references?
Very good question. So if you use synthesized setters, and actually either with the copy or the retain sort of attribute, those things are going to be retained implicitly. So you're going to have to release them in your dialog method. So even if you've avoided writing all this code in your setters and your getters, you've got synthesized accessors for for some property that are copy or retain, then you'll need to override dialog and release those instance variables. In that case, you would typically access the IVAR directly and say, IVAR release. Does that make sense? Any other questions about this or anything relating to assignment 1 that you forgot about, but you just realized that you wanted to ask me about because there's only 1 minute left in class? No. Okay. For any further reading on these topics, there's a couple documents that I'd recommend you check out in your copious free time. The first one is the Objective-C 2.0 programming language. Kind of covers the whole gamut as far as Objective-C goes. But 2 bits within there that you might find interesting after this lecture are defining a class and declared properties. It might fill in some gaps or clarify some things that maybe went by a little too quickly. The other thing I would recommend checking out is the Memory Management Programming Guide for Cocoa. Now keep in mind, there are probably 2 versions of this out there on the web. There's one for Mac OS X, which will have references to garbage collection, which you cannot use on the iPhone. Doesn't exist on the iPhone. There is a version for the iPhone, which doesn't mention garbage collection. So yeah, that pretty much covers it for today. So see you all on the email list.
For more, please visit us at stanford.edu.